unfortunately, Balint, our CEO, is not here with us because he's on a business trip in the US. So he are going to join via Zoom. And if everything's fine, he's on this call. Balint, can you hear us?
Yeah, I can hear you.
We can't hear you. We can't hear you.
Okay, just a moment. Let me adjust it. And now, is it better?
Yeah, now it's fine.
Oh, okay, great.
So let's get started. I give the word to Balint, and he will share some thoughts.
Thank you, Adam. Welcome, everybody. I'm Bene. I'm the CEO of Bene Studio, and today we are having a great workshop. Bene Studio is a global consulting company with offices in Budapest, Boston, and we have colleagues from all over the world, as well as clients. We work with startups, with enterprises, and we always try to bring in new technologies and methodologies. So I hope you will enjoy today's workshop, practicing a bit of machine learning with the help of Adam today. And after the hard work, please enjoy the beer and pizza and play some darts if you joined in person. And let's meet virtually as well, join to our workshop LinkedIn group, because at Bene Studio, knowledge sharing is one of our core values. So we always try to share our experiences with you, with the whole developer community. So please enjoy today's workshop, and let's start it, Adam.
Thank you, Balint. Goodbye.
Bye, guys.
And let's get started. So today I'm gonna talk you about machine learning and neural networks and TensorFlow. And let me ask a quick question: who has experience with TensorFlow, perhaps? Raise your hands. Who has experience with Python? Cool. So I'm Adam. I'm working for Bene Studio since this April. I'm a full-stack developer. I have experience mostly in TypeScript and React and this kind of technologies. So I'm kind of a beginner in TensorFlow as you, but I will try to do my best and give some basic knowledge about this topic to you. And feel free to pause me anytime, ask any questions, and let me introduce Alex, who's my teammate, and he will assist me today. So if you have any questions or if you have any blockers in the code, feel free to ask me or Alex. Alex can go to you. I can go as well, but please first ask Alex for this. And yeah, let's get started. So what we will build today? Today we are going to build our own neural network using machine learning and TensorFlow. So what is TensorFlow? TensorFlow is a library which is primarily developed for machine learning purposes. The naming comes from these two words. Tensor means multidimensional array. Flow means graph of operations. So what is TensorFlow? Like I said, it's a free and open source software library for machine learning and AI. It has a particular focus on training and inference of deep neural networks. TensorFlow was developed by Google Brain team for internal use in 2015. and the TensorFlow 2.0 comes out in 2019, and this time it became available for everyone. TensorFlow can be used in a wide with a lot of programming languages like Python, JavaScript, C++, and Java. There are some key features of TensorFlow. So with TensorFlow, you can build, train, and deploy neural networks and deep learning models. It has its own flexibility because it can be used in a wide range of machine learning tasks. It is really scalable because it can run on CPU, GPU, and on TPUs, which stands for Tensor Processing Units. It has some powerful visualization tool called TensorBoard, which helps you to monitor and analyze your machine learning experiments. There are a lot of companies over the world who are using TensorFlow, like Airbnb, ARM, Coca-Cola, PayPal, Spotify, and so on. And yeah, so let me give you a quick intro to machine learning. So from the beginning of computing, the coding was the bread and the butter for developers. We are used to create applications by breaking it down to smaller composable problems which can be coded against. For example, if we want to write a stock analytic application that figures out the stocks, maybe the price divided by the ratio, we can write an application for it and get the values from a source and do the calculation and return the result. Or if we want to develop a game, we can also figure out the rules. For example, if we want to develop this brick and ball game, we can set the rules that if the ball hits the brick, then the brick should vanish and the ball should rebound, or if the ball falls off the bottom of the screen, maybe the player loses a life. We can represent this with this diagram. So in traditional programming, rules and data come in and answers come out. Rules are expressed in a programming language, and data can come from a variety of sources, from local variables up to databases. Machine learning rearranges this diagram where we put answers and data in, and we got the rules out. So instead of us developers figuring out the rules, when should the brick be removed, when should the player's life end, or what's the desired stock analytic, or for any other concept, we can do this with machine learning, and we do not have to figure out the rules. Let me show you this example. For instance, if we want to build a device which purpose is to do activity recognition, we would say that we might do the recognition based on the user speed. So let's say if someone is walking, the user speed is below 4 kilometers per hour, we can say that the user is walking. If it's faster, we can say that he's running. If it's more faster, we can say that the user is cycling. But we can't move this logic if we want to recognize if the user is doing golf. So our concept comes broken. And with machine learning, we can say that we have a bunch of examples, and we can label these examples, and we can say that this data is for, this is what walking looks like, and this other data set is for running, and this other data set is for cycling, and the neural network will learn this concept, and it can do the activity recognition. That's why machine learning is so powerful and exciting, because it's more than just a new way of doing the quite old things. It opens up much possibilities that were invisible before. So let's dive into it. So what is a neural network? How does it look like? Here is this diagram. So the first key component of a neural network is the input. It is the data or the values which is passed to the neurons. There are hidden layers or deep neural networks, which is working with this data, passing this data and do some calculation in it. Every line of these neurons has a weight. These values explains the strength of the connection between any two neurons. There are also a bias. It's a constant value added to the sum of the product between the input values and the respective weight. So if we add these values, in the end, we get the bias. And there's an activation function which calculates the output of the node based on its inputs and weights. Here is a meme from the internet. So machine learning in a nutshell, that the baby, how does a baby do machine learning? And some differences between AI, machine learning, and deep learning. So the machine learning is the first part of this diagram. It's using complex algorithms and deep neural networks to train the model. Deep learning. Machine learning is an application of AI that allows the system to automatically learn and improve from the experience. And artificial intelligence is an availability of machine to imitate intelligent human behavior. To show how neural network works, let's take a look at this set of numbers, and probably you can determine a pattern between them. So x equals -1, 0, and so on, and here are the y values, and probably you can easily figure out this equation that y equals 2 times x minus 1, and if you've done this, congrats, because you've just done the basics of machine learning in your head. So let's solve this problem with machine learning. Please open up this link. We sent this link in the reminder email, or if you don't have it, you can scan this QR code and open it via this. Raise your hands if you are ready. Everyone's ready? Shall we wait for a couple? Cool. So the first thing we need to do is to copy this workbook. So if we click on this file tab over there and click on save a copy in Drive, we can copy this workbook. Let me know if you're ready. Cool. So how to check TensorFlow version? Let's write this. So let's say import TensorFlow STF, new lines, and then let's say print opening and closing parentheses tf dot underscore underscore version underscore underscore, and we can execute this code cell with this button. If we click on it, it is going to connect to our virtual runtime, and it's going to execute this piece of code for us. And hopefully you will get this output, that 2.13.0. Please raise your hands if you're ready. Cool. So let's solve this equation with TensorFlow, which we were talking about previously. First, do the imports. So let's say import numpy snp, new line import, from TensorFlow import keras. Let's execute these two lines. In the left side of the code cell, there's a green check icon if it's been successfully executed. The next step is to define the layer for our neural network. So let's say layer equals keras dot layers dot dense, opening and closing parentheses, and let's say units equals 1, comma, and then input underscore shape equals opening and closing curly square brackets, and let's just say 1. And let's define our model. So let's say model equals keras dot sequential, and we are passing the layer to it. And let's execute these two lines of code. If you've done it, you created the simplest possible neural network that has only one neuron in it, and this first line of code does it. So we are calling this dense function, which we can use for defining connected neurons. There's only one layer in our model. It means that there's only one single unit in it, and it means that it has only one neuron. In keras, we can use this sequential word to define successive layers. we can define the shape of our inputs. For now, it is going to just one numbers, and yeah, and the next step is to set the loss and the optimizer functions of our model. So let's say model dot compile opening and closing parentheses, and let's say optimizer equals and sgd as a string, and the loss equals mean squared error. And let's execute it. So in the neural networks, you have probably heard that for machine learning you need to do a lot of math and calculus, but there's a good news that TensorFlow does a lot for us. And these two functions are the most important, which you need to aware of that. So let me explain what these two functions does for us. So given this neural network, which has absolutely no idea what's the connection between the x and the y values, so it makes a random guess that y equals x plus 3. Then the loss function measures it, how bad or how good was this guess, and it takes the input values, test it, and send a constant value to the optimizer about how good or bad guess it was. And based on that, the optimizer function are going to do another guess, and it passes this guess to the loss function, and after that it will take another guess, and so on, and we are do this iteration until we get 100% accuracy in positive, if we are positive. So let's solve this equation. First thing we need to do is represent the known data. So let's say xs equals np dot array, opening and closing parentheses, and let me copy these values from here, all of them. So it has to be in an array, and it should be float. So -1, 0, 1, 2, 3, and 4. And the first and the second argument is the D type, which equals to float. And we are going to do quite the same for the y values. So ys equals np dot array, opening and closing parentheses, opening and closing square brackets, and let's copy the values, and -3, -1, 1, 3, 5, and 7, and the D type equals to float here as well. The second thing we need to do, we want to train our model with this data. So let's say model.fit and we are passing xs in it, ys in it, and the third argument are going to be the epochs, which is going to be 500. This third argument defines the number of iterations inside the neural networks. So we pass in 500. So our neural network will do this optimization and loss functions cycle 500 times. And if we execute it, we can say that it started to run and execute the epochs, and yeah, and after that, we can check with a value if our model works correctly. So if we pass in 10 and we say that this should be, y should be equal to times x minus 1. So if we pass in 10, it should be 2 times 10 minus 1, so it should be 19. And we can do that by saying model dot predict, opening and closing parentheses, and opening and closing square brackets, and just pass in 10.0. And let's say result equals to that. And after that, let's print this result. Raise your hands if you got the result. Yeah, sorry. Raise your hands if you're ready. Raise your hands if you need some seconds. Cool. So we got, I got the result 18.999 and so on. I guess you got quite the same result, but we said we are expecting 19. The reason for that it's not equals to 19, there are two main reasons for that. The second thing is that we only train this neural network with 6 points, so it's not a big data set, and there's no guarantee that for every x there will be this equation for the y's. The second reason is that neural networks deal in probability, so it's not fixed that you got this result. Can we move on to the second exercise, raise your hands if you need some more time. Do you need time? No, I'm sorry. I'm confusing a bit. Let's move on to this exercise. In this exercise, we are going to build another neural network, which will predict the price of a house according to a simple formula. So if we have a house which pricing, sorry?
How can you measure how good is the model?
You can measure with model.evaluate, and also you can check the loss of the current epoch, but we will talk a little bit more about model evaluation in the second section. In this exercise, we are want to predict that how much is the pricing for a house. So let's say 50K is the house cost and 50K per each bedroom. So that one bedroom house costs 100K, a two bedroom costs 150K, and so on. And we want to create a neural network that learns this relationship so that it would predict a 7-bedroom house as costing close to 400K. And let's start it. So here we have this Python function. So let's define the data set first. So let's say xs equals an empty array, ys equals an empty array as well. And we are going to fill these two arrays with values. So let's say for e in range opening and closing parentheses 1, 10. And next line, xs dot append e and ys dot append opening and closing parentheses, and let's say 1 plus float e multiply by 50. Like this. So for xs is going to stand for the number of bedrooms, and this is going to stand for the cost of the house. Cool. We need to transform these two arrays into NumPy arrays. So let's say xs equals np dot array, opening and closing parentheses. We are passing in xs, and we are saying that the type should be equal to float. Let's do the same for device. Ys equals np dot array, opening and closing parentheses, ys, comma, and the type equals float. Next step is to define the layer. So let's say layer equals keras dot layers dot dense. We need one unit, so units equals 1, and the input shape is going to be an array which is with a single value 1. Let's define the model next. So model equals keras dot sequential, opening and closing parentheses, and we are going to use optimizer equals SGD, and the loss function is going to be the same as before, mean underscore squared underscore error. The next step is to train our model. So model dot, sorry, I've done a typo, so sorry. Here we are passing the layer inside in this line. And the next step is to set the loss and optimizer functions. And in the end of the function, after the return, but before that we need to train the model. So let's say model.fit. The first argument is going to be the x s, the second is the y s, and let's set the epochs equals 4,500. And in the end of the function, we are returning the prediction. So let's say return opening and closing parentheses, and let's say model.predict opening and closing parentheses, and we are just passing this y new parameter from here. And let's execute this cell.
Do we really need 4,000 people?
Yeah, because it's not important, but for now we are saying that we are working with this quite large number, but it can be, I don't know, 100 as well, and probably we are going to get pretty accurate prediction with that as well. Let me know if you are ready. Cool. So the next step is to execute these cells, and this is going to run the epochs. So for me, it's executed successfully, and we get a quite accurate value, like 400.006, and it seems that our neural network is working properly. Now we are taking a 10-minute break. So let's see you all at 8:20. And click on Save, and then click on Connect. Let me know if you have successfully connected to this virtual runtime. For me, it's still connecting. Cool. And if you successfully connected to a runtime, let's execute this first cell. It's just basically do the necessary imports and set some seeds for TensorFlow and NumPy. Also, we are declaring class names for benign and malignant. We are defining some constants in the beginning, and that's it. After you successfully run this, start this second code cell. It is going to take a while because we are going to download a small part of ICI dataset, and this function downloads it for us and is extracted, but it's around, I don't know, 5 gigabytes, so it takes a while until it finishes. Let me present what are going to be the steps of this program. So the first step is going to be this function, which I mentioned. We are going to download and extract the images. The second step is going to be to label the images and generate some CSV files from it. The next step is going to be that we are going to load the data into Pandas data frames and TensorFlow datasets. After that, we are going to load and decode the images. If we done it, we are going to prepare this dataset for the training. Then we are going to build the model, train it. Next step is going to be to evaluate the model with the test data. Okay, so until it finishes, we are moving a bit forward, then moving a bit back. So the next step is going to generate CSV from these files. We are skipping this step until the download finishes for you. But not to waste your time, let's do the data loading here. So in the third cell, in this cell, which is starting with these 3 lines, we are going to load the CVS data into pandas data frames. So under this line, we are saying that df underscore train equals pd dot read underscore CSV, opening and closing parentheses, and this function takes the file path as first argument. So we are saying that train underscore metadata underscore file name. In the next line, we are going to do the same for the validation data. So let's say the f underscore valid equals pd dot read underscore CSV, opening and closing parentheses, and we are passing in the valid metadata file name in it. After that, we need to uncomment these few lines. Let's just delete the hash marks from the beginning. It's just calculating the length of these files, and here we are printing it. And the next step is to load this data frames into TensorFlow datasets. In order to do that, let's say train underscore dataset equals tf dot data dot data set dot from underscore tensor underscore slices, double opening and closing parentheses. The first argument we are going to pass in that the f underscore train, opening and closing square brackets, and we need the file path first, and then the labels. So df underscore train square brackets and label as a string. Let's do the same for the valid data frame. So valid underscore data ds equals tf dot data dot data set dot from underscore tensor underscore slices, double opening and closing parentheses, and then df underscore valid. We need the file path like before, and then the label. Let me know if you successfully typed these lines of code.
Can you zoom out to see the whole line?
In or out?
Out.
Sure.
Okay.
Is it visible now on the end? Cool. Then I leave it as it is. Let me know if I should zoom in. Who are ready? Cool. I see most of you ready. Let's check if the downloading and the extracting finished for you. Can you please scroll up and check it? Let me know if it hasn't. Is there anyone who is still downloading and extracting? Is it still?
Yeah, still the last part is
Is it downloading or
it's downloading.
downloading? How much is the estimated time? What does it say? 3 minutes. Wow. Yeah, sorry. It's done? Cool. So if it's done for everybody, please execute this second cell, which is going to generate CSV for each set. And it will label our images. So this function takes the pet as the first input and the dictionary as a second. And we are going to label nevus and seborrheic keratosis with 0 because these two types of skin diseases are benign. And we are going to label melanoma with 1 because it's a malignant type of disease. And if it's done, let's raise your hands, please. You can check also in the left panel. Here is this folder button. You can check the files in your runtime. So you can open up this test CSV, for instance, and you can see that in the first column we have the file path, and in the second we have the labels. And this file path is a nevus, so we labeled it with a 0. But if we go to basically to the end of the file, we can see that for melanoma we set the labels as 1. And raise your hands, please, if you need more time. So everyone's ready? Cool. And let's execute this piece of code which we typed in recently. And we will see that we have 100 training examples, 1,000 training examples, sorry, and 150 validation samples. So now that we are loaded the data sets, let's decode our images. And in order to do that, we have this decode image function. And first, let's decode these GPEGs into 3-dimension tensors. To do that, let's say image equals image tf dot image dot decode underscore GPEG, opening and closing parentheses. The first argument is going to be the image, and the second is going to be channels equals 3, because we need a 3-dimension tensors. Then we are convert these uint8 tensors into floats. To do that, let's say image equals tf dot image dot convert underscore image underscore d type, opening and closing parentheses, and we are passing the image in, and the second argument is going to be the type, which is going to be tf dot float 32.
You have
Thank you so much. And the last step is to resize our image. And we can do that with image equals tf.image.resize, opening and closing parentheses. We pass the image in. And for the second argument, we are passing an array. And let's say to 299 and 299. And let's execute this code. Please raise your hands if you need some time. Cool. Let's move on. As the next step, we are going to prepare our data set for the training. The first step is to uncomment these two lines here. And then we are going to finish this prepare for training function. The first step is to shuffle the data set. So let's say ds equals ds dot shuffle, opening and closing parentheses. And we are setting the buffer size, buffer underscore size equals shuffle underscore buffer underscore size. Then we are going to repeat this data set. So let's say ds equals ds dot repeat. We do not passing any argument for now. Then we are split our data set into batches. So let's say ds equals ds dot batch, opening and closing parentheses, and let's pass in the batch size, which is coming from the arguments, the parameters, sorry. And for the last step, we are going to prefetch the data set. In order to do that, let's say ds equals ds dot prefetch, opening and closing parentheses, and we are passing the buffer size, which is equals tf dot data dot experimental dot auto tune. And after that, we should uncomment these two lines of code. And let's execute this code cell. So under this code cell, we can see what we did. We cached the data set after we shuffled it to be in random order. Then we repeated it. So when every time we are iterating through the data set, it will keep generating samples for us, and this will help the training. Then we split our data set into smaller pieces. For now, we are splitting it to 64 set, and in the last step, we are prefetched we've done the prefetch, and this will enable to fetch the batches until the model is training. So let's uncomment these two lines in the next cell, and let's execute it. And here we are going to see some example images which we are going to use for the training. For this purpose, we are using matplotlib. Here in the beginning, we defined it as PLT. It's just a UI library for NumPy and Pandas. And here you can see some images with the labels. And you can see that it's really hard to differentiate between a benign and a malignant skin disease. Has it been printed for all of you? Most of you, probably. Can we move on? Raise your hands if you're ready. Cool. So the next step is to build our models. In the earlier section, we resized all our images to 299 and 299 pixels. And the reason for that was that we are going to use this Inception V3 architecture, which is a pre-trained model for this kind of purposes. And it's coming from the TensorFlow Hub library, where there are some pre-trained models available. So let's uncomment this line where we define the module URL. In the next line, let's define our model. So let's say model equals tf.keras.sequential, opening and closing parentheses, and opening and closing square brackets. And let's say hub dot capital key keras capital L layer, opening and closing parentheses. We are passing the module underscore URL. Then we are defining the output underscore shape, which is going to be an array with 2048. And we set trainable to false, because we do not want to train this model. We are going to use the pre-trained weights. And we are going to pass another layer for the output, which is going to be tf.keras.layers.dance with a capital D, opening and closing parentheses. And let's say units equals 1, and the activation equals sigmoid. After that, let's call the build. So let's say model.build, opening and closing parentheses, opening and closing square brackets. As the first argument, we are passing none. The next one is 299, 299, and 3. Then we are setting the loss and the optimizer functions with model.compile opening and closing parentheses. For the loss, let's equal it to loss. It has been declared in the first scope. And for the optimizer, let's equal to optimizer, same as for the loss. And for the matrix, we are going to pass an array with a single string called accuracy. And in the big end, we are saying model.summary, which will print some values for us. And let's execute this code cell for us. Check if we've done some typos or not. Okay, so let's move on. In the second block, we are going to train our model with our data set. The first thing we need to do is to uncomment these two lines. The first one is defining the model name for us, and also in the next line we are defining a model checkpoint, which is going to be a callback during the training. So let's train our model. To do that, we can say model.fit, opening and closing parentheses. The first argument is going to be train_ds. Next one is going to be the validation_data equals valid_ds. The next step is to define the steps per epoch, which is going to be equal the number underscore training underscore samples divided by the batch size. Don't forget to take 2 slashes here. It is going to be round our the results to an integer. In the next step, we are defining the validation steps, which is going to be n number underscore validation underscore samples divided by the batch size. We are set variables to 1. We set the epochs to 25, and we are passing the callbacks, which is going to be callbacks equal opening and closing square brackets, and we are passing the model checkpoint in it. And sorry, I've made a typo here. It should be batch size, not just batch. And then let's execute this piece of code. It is going to train our model with our samples. As you have seen, we have quite a lot of images, so it is going to take a while. In the meantime, if you have any issues, we are free to help. And we are passing this model checkpoint callback, which is doing that, which is saving the best weights for each epoch, and we can get better heights at any time. And you asked that how can we check how accurate our model is. We can check the accuracy in every epoch. So if you pass in a callback to the model, which you checking the accuracy inside, you can stop the training. It's quite fast for me, but it's probably a bit slower to you. Let me know if you need help, if you need time. Raise your hands. Oh, sorry. Excuse me, guys. In conscious of time, I'm moving on. Alex are available for help. In the next cells, we are just going to do one more code modifications. If you successfully run the epochs, you can see that here it prints for me that validation loss did not improve from 0.4.852, which means this model has the best weight. So let's check for this model in the file explorer. If you toggle, for me it's 0.4385, so it's going to be this model. If you do a right click on it and click on rename file and copy the whole name of the model, here if you scroll down, here is a line which called model.loadWeight. Here we need to paste this string inside, and then we can execute these cells. Now in this cell we are just loading the testing set. We are prepare this data set for the testing, and then we are evaluating our model. And here you can see that the loss is 4.45 for me, and the accuracy is 0.80. If we execute the next cell, we can check the accuracy after setting the threshold. So this function basically sets a threshold 23 for us. So that it means that if an image is probably 23% malignant, we are going to assign it as a malignant. Otherwise, we are assign it as a benign. Yes, please.
Can you show me where to put the string?
Yeah, sorry. So here, in the after this line model.load weights.
You just commented out that.
Yeah, just comment this out and copy the file name of the best weight, which you can get from the logs here.
Where we have to copy that from.
So if you open up the file explorer, you can check for which is ending this.
Sorry, can you please repeat how we should choose which one?
So have you successfully run these epochs? And it says that in the end of that, validation loss did not improve from, and here we can see a numeric value. And here, if you open up the file explorer, you are going to see some models saved. And for me, the validation loss was the best at 0.438. And you can choose probably that one, but for me it's rounded, so it's going to be 439. And in conscious of time, let's move on. And let's execute this code cell. And in the beginning, let's run the prediction. And for me, firstly, I've tested our model with a nevus, and we can see that it's 92% benign, which is great. And for the second image, which is a melanoma, it's 62% malignant, which is also great. After the workshop, I'm going to create a blog post where all the codes snippets will be available. So if you got stuck, don't worry, you will get the code. But we prepared a quiz to you, and please open it up. So please go to menti.com and enter this code. It's 22, 50, 52, and 26. And also you can use that QR code as well. Sorry, I forgot to mention. Bocsi, 52-26. So, are you ready? Raise your hands if yes. Have you entered your name as well in the quiz? Who needs some time? Can we start? Alex? Alex? Can we start? Okay, so let's start the quiz. So answer fast and you get more points. The first question is the following. What programming tool are we used to in this workshop that requires no setup and works with most of the browsers? Everyone has voted. Cool. Oh, sorry, I was too fast. So the right answer was Google Collaboratory. Congrats if you guessed the right. Next question. In traditional programming, what usually comes first, writing code or figuring out the rules? Yeah, figuring out the rules is the right answer. So someone voted for the magic. We are hiring, so please join us. What is the new programming paradigm introduced by machine learning, where we put the answers in and data get rules out? Cool. Most of you got the right answer. Question 4. How many points did we use to train the neural network in the Hello Neural Networks section? 3, 6, 10, or 500? So it was 6, the epochs was 500. Next question. What type of diseases are we trying to classify in the second section of the workshop? Cool. Moving on to the next question. What pre-trained model are we used for transfer learning? Inception v3, ResNet, MobileNet, or SuperDuperNet? Thanks for the thumbs ups, guys. Most of you got the right answer. Seventh question is, what is the purpose of using model checkpoint callback during the training? To take model selfies, to save the best weights during the training, to create checkpoint for every model layer, or to print the model's progress? Cool, so the right answer was to save the best weights. It's a checkpoint, so we are not creating it, just using it. Moving on to the 8th question. What type of optimization technique is used in the workshop to improve the model's performance? Yeah, it was the stochastic gradient descent, called SGD. Next question is, what type of services does Bene Studio specialize in? Catering services, interior design, web, mobile app development, or automotive repairs?
I think we see the catering part.
Yeah, that's true. Yeah. Cool. Next question is, what type of content can you find on Bene Studio's blog? Gardening tips, travel recommendations, design development and technology insight, or fashion trends? Nice, 4 of you voted for fashion trends. Cool. Last but not least, question is, where is Bene Studio primarily located? In Paris, in Budapest, in Boston, or in London? Cool. Budapest is the right answer. And moving on to the last question. What is the primary industry that Bene Studio has worked with as seen in their portfolio? Agriculture, healthcare, entertainment, or sports? Yeah, the right answer was healthcare. And let's see our winner. So the winner is ZB. Please stand up, ZB. And you won this merch. Please. Congrats. And thank you all for coming. We prepared some pizza and beers, as you may know. Please enjoy it. And if you have any questions, please feel free to ask me. Thank you.